Hi, ladies and gentlemen. My name is Simon Timpler from the International Food Safety and Quality Network. Welcome to edition 85 of the Food Safety Fridays webinar program, your weekly opportunity to get some free education and a free certificate of attendance by an expert speaker. The way you can do that is obviously sponsored. It's supported by some kind organisations, AIB International, Metal Toledo, Trace Analytics, and Safety 360, who help to bring these to you free of charge. Just to let you know, if you already know lots of you in the sidebar, you can type your comments and say hello to each other throughout. And we pick your questions up at the end of the webinar. Okay, today's subject is environmental monitoring with Kantha Chennai from AIB International. Kantha's the Director of Microbiology at AIB International. And are you there, Kantha?
Yes, sir.
Can you switch your webcam on? Okay, yeah, there you are. Resplendent. Nice to have you with us, Kantha. Can you tell the audience where you're calling from today?
Okay, I'm located in Manhattan, Kansas, United States.
Okay, and it's a bit chilly there at the moment, is it?
Yes, sir. It's chilly over here. It's cold, and if anyone wants to experience, they are most welcome to come to Kansas.
Well, even though it's cold there where you are, and it's cold in Manchester in the UK, we're hoping to bring some warmth to the audience with our presentation today. So if you want to get your slides ready, Kantha, I'll talk about next week, what we've got coming up next week, okay?
Okay.
Right, ladies and gents, in the sidebar you will see Food Safety Live next Tuesday, because we've got 10 expert speakers, 10 30-minute sessions, and I will just run through them quickly. If you have a question about supplier management, human resources in food production, meeting HACCP requirements of GFSI standards, effective food safety training, food defence, metal detection and X-ray inspection, FISMA, compressed air safety, recalls and traceability, or how to ensure food safety with small suppliers, 10 separate Q&A sessions, 30 minutes each, free consultancy to get your questions answered. So next Tuesday starts at 7 a.m. Eastern, and that's lunchtime over here in the UK. So register for that, it's free, and we'll see you next Tuesday. Fantastic. Okay, Kantha, I'll be back for the Q&A later, but for now, I'll hand you over to Kantha for the presentation.
Oh, okay.
Okay.
Good morning, everyone. Welcome to Environmental Monitoring webinar. My name is Kantha Chennai. I'm the Director of Microbiology at AIB International, located in Manhattan, Kansas, United States. Before I get started, let me go over a little bit of housekeeping. The duration of this webinar is 60 minutes with a 50-minute talk and 10 minutes for Q&A session. Please hold your questions until the end of the webinar, or meantime, questions can be entered via the Q&A widget on the right-hand side of your screen. The questions will be answered sequentially. If there are any unanswered questions within the allotted time, then it will be answered later individually. Agenda. Following is today's agenda. First, I would like to talk about the importance of food safety. Second, I will talk about as to why we need an environmental monitoring program. What does the US FDA FESMA say? FESMA stands for Food Safety Modernization Act. Then I will spend most of my time talking about how to design an effective environmental monitoring program. Here I will focus on the importance of zoning concept, indicator bacteria, establishing a baseline, product testing, corrective actions, documentations, summary, and we will finish off with the Q&A session. Please note that throughout my presentation, I'll be using an acronym EMP, which stands for Environmental Monitoring Program. Although this presentation is US-centric, the concept and principle of environmental monitoring program can be applied to all types of RTE foods, that is ready-to-eat foods manufactured globally. Food safety, top priority. Achieving food safety is the topmost priority for any food manufacturer. Maintaining hygiene condition in the processing environment is important to maintain the quality and microbiological safety of the finished product. Microorganisms are generally introduced into the food processing environment through a wide range of raw ingredients such as pests, air, equipment, water, and most importantly, through employees. According to ICMSF, that is International Commission on Microbiological Specifications for Foods, good hygiene practice is very important for food safety. Although we enjoy one of the safest food supplies in the world, foodborne illness remains a common foodborne illness outbreak remains common in the United States and around the globe, where it affects millions and kills thousands every year. Additionally, tainted food has cost the food industry billions of dollars in recalls, lost sales, and legal expenses. Every week, one can see hundreds of recalls due to contamination of pathogenic bacteria. Why do we need an environmental monitoring program? The past data clearly show that a substantial amount of foodborne illness outbreaks results from poor hygiene practices. Even though the facility has validated kill step, the post-lethality recontamination remains a serious concern and challenge. At the end of the day, it's the responsibility of the food manufacturer to make the finished product safe, and you all know that. Here, it is critical to maintain and monitor the hygiene environment in the food processing facility for the production of high quality and safe food products. This is where environmental monitoring program comes into picture. To achieve high quality hygiene standard, one need an EMP, and there is no alternative for EMP. EMP is the only way to evaluate hygiene condition of a facility. Why do we need an EMP? Let's understand what is EMP and how it is beneficial to us. This is very important. EMP will measure the overall effectiveness of sanitary design, personal practices, and operational methods. A properly implemented EMP will identify any microbial issues in these three segments, which are very important and provides crucial information on overall hygiene or health of the facility. EMP will verify that cleaning and sanitizing procedures are adequate to keep indicator organisms in check and any pathogenic organisms of particular concern in control or in check. That means EMP acts as a surveillance system or early warning system for microbiological hazards. So let's understand what does US FDA FSMA say. FDA's Food Safety Modernization Act, which was signed into a law in 2011, shifted the main focus from addressing food safety failures to preventing it. According to the FSMA, one must conduct environmental monitoring and product testing if a ready-to-eat food product is exposed to the environment before it is packaged and the packaged food does not receive a treatment that would significantly minimize an environmental pathogens. So if these two are applicable to your facilities, then you need to have EMP program. The statement is straight and clear. If you manufacture a RTE product that is exposed to the environment before it is packaged and does not receive any lethal treatment that significantly reduces the identified pathogen, then you must implement an effective environmental monitoring program. According to FDA, environmental monitoring and product testing are verification activities. I hope this is clear to everyone. Designing an EMP. Let's understand what it takes to develop an effective environmental monitoring program. An effective EMP consists of 10 critical components or 10 steps. It starts with forming an EMP team, identifying zones, choosing an indicator bacteria, determining sampling and frequency, labeling and shipping, determining a baseline, product testing, establishing corrective actions, verifications, and documentation. The first step in establishing an effective EMP is to create an EMP team. So the first task is to bring together individuals familiar with the operation to form a team. This group will be your EMP team. The second task is to choose a team leader who knows in and out of facilities operations. The EMP team may include the plant quality manager, the plant or corporate microbiologist, line supervisors or operators, sanitation supervisors or workers, and plant engineers. And make sure to keep a separate EMP file and list the EMP team members' name, including the contact details of the EMP team leader. This is very, very important. This is the first step of building an EMP program in your facility. So once the EMP team is assembled, formed, it is vital to understand the process flow. Sorry. Once again, so it is important to walk the plant to determine and identify areas where the product may be vulnerable to adulteration or pathogenic or bacterial contamination. Using facility map, identify the hygienic zones, identify specific sampling sites based on harborage points on level of risk within each zones or areas. If your facility does not have a food safety microbiology expert, then you can always contact an experienced outside expert, or you can consult a person from outside who has experience in identifying zones. Step 2, the second and most important step is to mark the zones in your facility. This is very, very crucial. To identify a sampling point, the best practice is to use the zoning concept. Using sanitary zoning concept, divide the facility operations into 4 zones such as Zone 1, Zone 2, Zone 3, and Zone 4 based on vulnerability of a RTE food that is exposed to the environmental contaminations. So after walking through the facility, identify sampling points based on the vulnerability of a RTE food that is exposed to the environmental condition. If you think that there is a good chance that product is getting contaminated because of environmental issues, then mark those things as zone 1, 2, 3, and 4. So it is critical for the EMP team to define what constitutes highest risk area, that is zone 1, to lowest risk areas, for example, zone 4 for product contamination. So zone 1 is considered as the sensitive areas where the product is being manufactured, and that is the high risk area. And the zone 4 is normally a place away from product contamination, product contact surface area or manufacturing area. So those are considered as the lowest risk. So identify these things based on the vulnerability of a food product that is exposed to environmental contamination. Zone 1. Zone 1 is the most sensitive to contamination as mentioned earlier, and it includes all direct food contact surfaces in the plant, Example, blenders, conveyors, utensils, work tables, etc., etc. So it is recommended not to swab for pathogens in zone 1 environment, as this is not an effective way to capture product contaminations. Please note this point again. It is recommended not to swab for pathogens in zone 1 environment, as this is not an effective way to capture product contamination. But you can always use indicator organisms for zone 1. So this is very important. So do not swab zone 1 for pathogens, and you can effectively control your zone 1 contamination using indicator organisms, which I'm going to discuss later. So, and another important factor in zone 1 sampling is the total percentage of testing from zone 1 is normally 10 to 20%. Okay, so suppose if you have 100 swab sample, and if you're wondering like how many swab samples should I take from zone 1, zone 2, zone 3, and zone 4. So zone 1 normally, like between 10 to 20% of the samples are taken from zone 1. In rare cases, such as continuous positive zone 2 or positive finished product or a recall situation, then zone 1 should be tested for pathogens. Otherwise, using indicator organisms, you can do a good job of maintaining hygienic condition in zone 1 area. Zone 2, these are non-food contact areas in the plant that are closely adjacent to food contact surfaces. Example, equipment frame, maintenance tools, drip shields, chain guard housings, etc., etc. In general, this is the area, this is very important, this is the area where environmental contamination is most likely to affect the safety of the finished product. So this is the most important area in your environmental monitoring program. So hence, here maximum number of samples will be taken from zone 2. Okay. So the focal point of zone 2 testing will be to validate the equipment and sanitary design. So that is the focal point of collecting swab sample from zone 2, to validate the equipment and sanitary design. And the total percentage of testing from zone 2, as mentioned earlier, here we'll be taking more samples, and normally 40 to 50% of the samples are taken from zone 2 area. That is, highest number of samples are taken from zone 2 areas. Please note this. Zone 3, these are non-food contact surfaces that are not close to zone 1. Example, walls, floors, drains, ceilings, pallets, etc. So as soon as somebody talks about zone 3, you should get walls, floors, drains, ceilings, pallets in your mind. So if zone 3 is contaminated with a pathogen, it can lead to contamination of zone 2 through the actions of humans or movement of machinery. So this is very important. So why we need to keep zone 3 in good shape? Because the actions of humans and equipment's movements can lead to zone 2 and zone 1 contamination if zone 3 is already contaminated with pathogenic bacteria. So you need to do a good job of maintaining hygienic conditions in zone 3 too. The total percentage of testing from zone 3 is normally around 30 to 40%. So second highest swab samples are taken from zone 3 areas. Zone 4 uh, refers to the areas removed from the product processing areas. Example, employee break area, office area, maintenance room, etc. If zone 4 is not maintained in a good hygienic condition, it can lead to cross-contamination of zone 3, 2, and 1. But zone 4 is not considered as a high risk for potential cross-contamination. Therefore, normally the percentage of testing from zone 4 will be less than 10%. Please note the number of swab samples in zone 4. It is usually less than 10% from zone 4 area. So don't waste your swab samples. Take maximum swab samples from zone 2, followed by zone 3 and zone 1 and zone 4. Third step or component in EMP is choosing an indicator bacteria or microorganism. When it comes to choosing an indicator microorganism, the most frequently asked question is why indicator microorganisms? Low prevalence of pathogen limits the practical significance of direct pathogen testing. So pathogens are present in low numbers, so it's going to limit the practical significance of direct detection. That's why we go for indicator bacteria. And also indicators are non-pathogenic microorganisms that may be naturally present in the processing environment, including food and water. Also, indicators are high in numbers and easy to enumerate. That means easy for the laboratory assays to count the microbes in a facility. Positive indicator means a possible contamination and a risk of foodborne uh, disease. Example for indicator microorganisms are total aerobic plate count, total coliforms, E. coli biotype 1 counts, fecal coliforms, enterococcus species of fecal origin, etc., etc. Please note that indicator organisms are not a substitute for testing pathogens. So you cannot say that I'm testing Enterobacteriaceae, so there is no salmonella. You cannot make that statement. So these are not a substitute for testing pathogens, but it gives a very good information based on which you can take necessary corrective actions, assuring the safety of the finished product. Indicator bacteria microorganisms. As mentioned earlier, it is important to choose the right indicator bacteria. For example, if it is a wet processing facility, then Listeria monocytogenes is the main concern. So it would be appropriate to choose Listeria species as indicator organism. For dry processing environment, Salmonella is the main pathogen of concern. So then it would be appropriate to choose Enterobacteriaceae as indicator organism. So US FDA recommends testing for Listeria species because doing so it will detect both Listeria monocytogenes, which is the only pathogen among Listeria species, as well as species of Listeria, and allow you to correct situations that could potentially lead to contamination with Listeria monocytogenes. Step 4, sampling and sampling frequencies. It is important to specify an appropriate number of selected sampling sites. Test both food contact surface and non-food contact sites at each sampling time. Please note this. This is very important. At each sampling time, test both food contact surface and non-food contact surfaces at each time. Design a program such that it covers all potential sites within a defined period of time. Example, like 1 month or 2 months of time. Make sure you cover all the potential food contact surface or non-food contact surface in your facility that can potentially cause product contamination. As per the latest FDA guidelines, even the smallest processor would collect samples from at least 5 sites of food contact surface and 5 sites of non-food contact surface on each production line. So this is the most commonly asked question, like what is the minimum samples that I need to take from a food contact surface and non-food contact surface. So recently released FDA guidance clearly says that even the smallest of small processor, they need to collect 5 sites of food contacts and 5 sites of non-food contact surface on each production line. Please note this. Larger processor should determine the appropriate number of sample sites based on the size of the plant and the risk for product contamination based on the risk assessment. Timing and frequency for collecting environmental samples. Again, this is another important commonly asked question. Timing and frequency plays an important role in identifying the harborage sites and potential bacteria. As per the latest FDA guidelines, excuse me, the most important time is several hours into production or preferably just prior to cleanups. In most cases, it is quite normal that after the production is done, after cleaning and sanitizing, people try to take swab samples, make sure that it's negative, and in most cases it is negative. But the recently released FDA guidelines clearly says that uh, collect swab samples after several hours into the production. Example, in an 8-hour shift operation, the most suitable time to collect swab samples is after 3 to 4 hours beginning of the operation. So I hope this is clear to everyone. Like, in an 8-hour shift, like, try to collect the swab samples in between the operations, that is like 3 to 4 hours beginning of the operation. Also, it is suggested that not take swab samples too close to the time when surfaces have been sanitized. Otherwise, it makes no sense. Timing or frequency of collecting environmental swab samples. The number of samples and sampling frequency should be based on risk. Let us discuss this topic with an example. Consider two situations in a RTE manufacturing facility. Product A that do not support the growth of Listeria monocytogenes, and product B that supports the growth of Listeria monocytogenes. As per the latest FDA guidelines, product A falls under low risk category and hence a lowest sampling frequency should be implemented. Product B falls under high risk category and therefore highest sampling frequency should be implemented. As mentioned earlier, I know you need to do a good risk assessment, and based on the RTA food or food that supports growth of pathogen or not, you have to come up with a good plan, like the lowest sampling frequency versus highest sampling frequency. EMP sampling tools and techniques. Sampling tools also play an important role. There are several options to collect environmental samples, such as using a swab, a Petri plate, a Rodak plate, a Petri films, etc. Sponge with a stick is one of the most efficient and cost-effective methods available for environmental swabbing. Recently, there is something called polyurethane sponge with a stick, and that is gaining a lot of popularity because it's going to retain more bacteria. For air sampling, I recommend collecting air samples using a small handheld air sampler, which is more accurate and effective than open plate method, which is very traditional, and I would say it's a crude method and not an effective way of collecting contaminations from air. So when I say like you have to implement an environmental monitoring program in your facility, you have to consider employees, you have to consider all the zones like zone 1, 2, 3, 4, water and air. Okay, so it includes all these important components. I also recommend implementing ATP bioluminescence assay, which provides real-time information on the microload on the food contact surface. ATP bioluminescence, ATP stands for adenosine triphosphate. It's a very good assay, although it will not tell whether it's a Salmonella, Listeria, E. coli, O157, Campylobacter, etc., etc. At least it will tell there is some micro load and you need to take immediate corrective actions. So higher ATP number indicates high microbes. That means you need to take appropriate corrective actions such as intensifying cleaning and sanitizing activity. Number 5, step 5, labeling and shipping. Collect the samples, preferably early in the week, and ship the samples with information such as date and time, location, microbiology test requested, and date submitted. Also, make sure you ship the swab samples in a cool box and test within 2 days for accurate results. I would like to use former US President Ronald Reagan's famous quote here. The quote says, trust but verify. Once in a while, submit a negative control swab, that is swab sent to the lab without being used, to make sure that the third party lab is doing a good job. Okay, so follow the trust but verify concept to make sure that your money is not wasted. You're getting good results for the money you invested. Laboratory testing of swab samples. One can analyze swab samples in-house or at an outside third-party lab. The recently released FDA guidance says that you should implement a scientifically valid environmental monitoring program in your facility. So what exactly mean by this? The sampling methods and analytical testing of samples should be consistent with those described in an authoritative reference or standard manuals such as FDA's Bacteriological Analytical Manual, ICMSF, American Public Health Association, etc., etc. And make sure that you have all these informations recorded in your EMP file. Step 6, establishing a baseline or target. This is important, and this is unique to your facility and products. So normally what happens, like people are asking me a lot of questions about, what is the baseline for my product in my company. And, it's, I always say that the employees or the staff are the best person to decide, because they know the product that they are working there, and they know the harbor sites in a facility, and they are the best people to decide. Don't ever copy this baseline or target from another company. So as I mentioned earlier, this is unique to your facility and for your products. So normally we use historical data, for example, last 6 months or 1 year data to establish baseline. You cannot start a EMP program day one having a baseline. That makes no sense. So use historical data, for example, last 6 months or 1 year data to establish a baseline. A site may test, for example, less than 50 CFU, that is colony forming units per 100 square centimeter, with 1 or 2 spikes. Then 50 CFU would be set as a baseline. I recommend you to review baseline every 6 months. That is very important. Don't establish the baseline and keep it for next 2-3 years and use the same baseline. That's not recommended. I recommend you to review the baseline every 6 months or at least every year to optimize the EMP program. Suppose, for example, when you start the EMP program, you have 500 swab samples uh, in 250 sites. So based on the results, you can increase or decrease. You can increase the swab numbers if you are getting more positive, and if you are getting negatives with the good sanitation cleaning practices, you can always decrease. So you are the best person, people to judge and optimize the EMP program. Otherwise, you guys are just wasting money and resources. So you need to review at least every 6 months and make sure that you optimize the EMP program, which is very, very important. Trends and corrective actions. This graph shows the trend and corrective actions. As you can see from the picture, the green line is the baseline or target. The yellow line is the maximum acceptable level. If the red line shows increasing trend, then it indicates early warning and you need to take appropriate corrective actions. So any increase in microorganisms should be monitored, as these results as are signal a positive deviation in the sanitary conditions. And appropriate corrective actions, example, change of sanitizers, change in sanitizing frequencies, etc., should be initiated to bring the values close to the baseline or below the baseline. And make sure to record all the results. That is very important. You need to record all the results and corrective actions procedures in the EMP file. Don't wait till you find a positive, then look for corrective actions. Make sure in a EMP file, when you start implementing, you have all the corrective actions written in your file. For example, zone 1 positive, what are the corrective actions? Number 1, 2, 3. Zone 2, in case of positive, what are the corrective actions? Action plan A, B, C, etc., etc. Everything has to be written in advance and document all the results and corrective actions. That is very important. Product testing, step 7. So one can include product testing of both raw materials and finished product to verify that existing preventive controls are effective or not. So this is very important. As mentioned earlier, according to FESMA and US FDA, product testing and environmental swabs are considered as verification activity. Please note this. This is not a validation activity. This is more of a verification activity. I do not recommend testing finished products for pathogens. One can build an effective environmental monitoring programs with selective indicator bacteria or microorganisms. Sometimes I hear from clients saying that they don't do any swab testing but do finished product testing. However, finished product testing as a sole means of controlling microbiological hazards is not a good strategy. Please understand this. Finished product testing as a sole means of controlling microbiological hazards is not a good strategy. One should not rely just on finished product testing, period. Okay. So I hope this is clear to everyone. Excuse me. Corrective actions for positive results, step 8. So this is one of the important steps in environmental monitoring. So whenever there is a positive or higher CFU than the target or baseline, uh, reassemble your team. First thing what you need to do is inform your team, reassemble, initiate a root cause investigation, use team's findings to improve operations such as increase cleaning and sanitation frequencies, repairs, employee traffic patterns, correct those things in case if there is an issue with the employee traffic patterns, increase the swab frequencies, verify the effectiveness, and finally monitor the situation. Some information about vector swabbing. I recommend doing vector swabbing in a rare situations where there is a repeated positives or a recall situation. Otherwise, I do not recommend a vector swabbing. Vector swabbing requires taking additional samples around the initial positive site. As you can see from the picture, initially there is a positive swab sample, and now you need to take additional samples around the initial positive site. Typically, 10 to 15 additional swab samples are taken in a starburst pattern, as you can see from the picture, in all the directions, including up and down, as seen from the picture. Sometimes it covers zone 2, zone 1, and zone 3 areas. That's okay, but you need to make sure that you collect additional swab samples. So the main purpose, this is another important question. The main purpose, what's the main purpose of vector swabbing? The main purpose, as I mentioned earlier, in rare situation where there is a repeated positives or a recall situation, you want to identify the source of contamination. So this will help to identify the source of contamination. So for source tracking, go for vector swabbing, otherwise it is not required. I hope this is clear to everyone. Step 9, verification. It is important to verify the number of samples and sampling sites with an increased sampling sites and frequency. So once in a while, it is important to verify with an increased sampling sites and frequencies. Sorry, excuse me. For example, instead of regular 40 samples, take 60 samples covering additional sampling areas or sites. So despite of increased swab samples, if you are getting same results or pattern, that shows that your EMP program is appropriate. I hope this is clear to everyone. So despite of increasing the swab samples and sampling sites, and if you are getting the same results or pattern, that shows that clearly shows that your EMP program is appropriate. Otherwise, if there is any significant deviation, you need to discuss the results with your team and again optimize the program after reviewing all the records. Number 10, documentation. As someone rightly said, if you haven't written it, then you haven't done it. So keep a separate EMP file or folder and have all the information such as EMP team, members name, contact details, sampling zones, indicator organism, number of samples, frequency, baseline or target, labeling and shipping information, results and predetermined corrective actions procedures. So you need to have all these things in your EMP file and make sure that you communicate all the vital informations of EMP with your team members all the times. And it's important to have a meeting once in 2 months or quarterly, based on the situation, and communicate all the updates regarding EMP program with your team. This helps in keeping everyone on the same page and helps to come up with a good strategy to address the microbial hazards entering into the finished product. Mapping. I also recommend recording all the results in a facility map as seen on this slide. So this is really useful. You can use different colors such as green, orange, or red to indicate negative, upward trend, and positive results respectively. Sometimes for a non-technical person, it might be difficult to understand the micro results, which are in less than 100, less than 10, more than 100. So all those things, it's very difficult for a non-technical person to understand. So, but if you have the results in the form of a facility map, it is very easy to understand. And I believe this act as a useful tool in addressing the contamination issues. As you can see from the picture, for example, right hand side, you can see all the drains are positive. Maybe the drain is flowing from top to bottom, or from down towards the top direction. So maybe one of these drains having some issue. If fixing one drain can fix all three problems. So this will act as a useful tool and also help in addressing contamination in general. Summary. Environmental monitoring program is specific to the individual food facility and to the individual operations within the facilities. This is very important. Please note that there is no one universal EMP program that suits the need of all the food manufacturing facilities in the world. The number of swab samples and sampling frequency should be based on risk assessment. Also, it is very important to choose a right indicator organism. This is very, very critical. Verify that the EMP program once in 6 months and optimize the swab samples, sampling frequencies, and sampling sites. It is important to document all the procedures, results, and corrective actions in an EMP file, and do not just rely on the finished product testing. As mentioned earlier, finished product testing as a sole means of controlling microbiological hazard is not a good strategy. From science point of view and food safety point, EMP is a very, very good tool. The three main important benefits of EMP are: EMP helps in determining the overall health of the facility. Number two, acts as a surveillance system or early warning tool for microbiological hazards. And number three, most importantly, it prevents the release of potentially contaminated finished products. So last but not the least, environmental monitoring and product testing are verification activities that provides valuable information on plants' overall hygiene condition. I would like to mention one more important point here. Common GMP issues can act as harborage points for microorganisms. So use weekly inspections. So weekly inspections to identify and remove any GMP, good manufacturing practices issues in the facility. So I always tell people that you are the best to decide and to fix the GMP issues. You are the best people because you're working in the facility. You know where the crack and crevices are, where the leakage happens during monsoon or rainy season, and where the birds enter, normally where the pest activities are more. So you know better. So you make sure identify those issues and fix those issues, and that will help in a greater way. The ultimate goal of EMP program is to prove that your company is operating in a food safety mode and preventing potentially unsafe finished products from entering commerce. Okay, so I think that's all I have for today. I think now it's time for a Q&A session.
Yes. Yeah, if you can stop sharing now, Camphor. Thank you very much for the very thorough and clear presentation. Excellent. Yeah, so if you can switch your webcam on, we'll get the Q&A. Lots of questions were asked. Can you just switch your webcam on, Camphor?
Yes, sir.
Yeah, lots of questions were asked during your presentation, and some of them were answered by other delegates. So what we need to do is get them, submit your question again. So I'm not going to scroll all the way down. I'm going to just pick up the questions from here. So Liz, what zone are slicer electrical cabinets?
Yeah, electrical cabins.
Cabinets. Yeah, your webcam's still not on, Camphor.
I'm not able to do this.
Oh, right. Shame.
Okay.
There you go. Yeah, there you are. Brilliant. Okay, yeah, so Liz is asking what zone are slicer electrical cabinets? So it must be, yeah.
So see if it is close to the product contact surface, I would consider that as zone 2, because in most cases equipment will have this electrical cabins. So consider that as an important zone, because frequently you are using your hand and touching those things, and again there's a good chance that you're touching the product again. So I would consider that as zone 2 areas.
Okay, thank you. Deo is asking, how can we make bacteria standards for each zone?
Bacteria standard.
For each zone. Set, I guess, levels of acceptable levels for each zone.
Okay, that's a baseline again. I think the question is more about how to set the baseline for each zones. As I mentioned earlier, it's based on your, 4 or 6 months of results. You can come up with your, the baseline. For example, in zone one, less than 100 coliforms, you can set it as a baseline. Again, it depends on the product. Less than 1,000, total plate count, you can consider that as a baseline. So these are some of the things, and of course, a pathogen has to be zero in zone one. Except in some countries, they have some baseline for listeria species, but otherwise in US, all the pathogens are zero in zone one. In zone two, probably you can have less than 1,000 coliforms and less than 10,000 total bacterial count and less than 10,000 again Enterobacteriaceae as a baseline. This is just an example, but at the end of the day, depending upon the product and depending upon the total shelf life, you need to come up with your baseline. I hope this.
Okay, thank you. Parker is asking, so what should I do if I've gone for 2 years and not gotten any positives? I am really swabbing some gross things. So no positives in 2 years. What should he do?
I'm having a hard time hearing the voice. Can I see the questions, Simon, if you don't mind? So when you scroll, can I see those questions?
Yeah, you should be able to see the questions in the sidebar. Okay,
So,
yeah, yeah. Parker is saying he's not got any positives for 2 years. So what should he do?
so in case of repeated positive, for last 2 years, I don't know like how you guys have handling the situation. If I was there, like if it is like more than 3 times continuous positive, I will go for vector swabbing and make sure I'll stop the line and make sure I'll go for comprehensive investigation. And sometimes you might have to dismantle the whole line and make sure that you fix those things and move forward. So this is very straight and simple science. If it is more than like despite of repeated corrective actions, if you're still getting positive, that means there's something wrong. So you have to, it's a red light on. Okay, so you have to make sure that you stop the production in that line and make necessary corrective actions. Sometimes you have to dismantle the whole things or increase the cleaning and sanitation frequencies in that area or change the employees. You have to try all those things. As I said earlier, you are the best person to decide those corrective actions for your facility based on the situation, based on the product.
Okay, thanks, Camper. Kevin is asking, should areas above product contact surfaces be considered zone one, two, or three?
Yes, that's a good question. Yes, the areas above the product contact surfaces should be considered as zone one because the dripping shields, the side walls, those can act as a source of contamination. Yes, that's a good question. You should consider that as a zone one.
Okay, thank you. Asia, what elements should be considered for performing the risk assessment?
Okay, the risk assessment, that's a very good question. Based on the product to water activity and shelf life, you can, come up with your uh, strategy plan, and that's the one of the important factor. If the product is supporting the growth of microorganisms, definitely it will be a high risk category. If the product does not support growth of microorganisms, then it will be considered as low risk category. But as I said, this is just one specific component that you need to give most importance. Apart from that, the post lethality exposed product, how you are handling that, that also plays a very important role. And again, the packaging component, if you're going with antibacterial packaging, or modified atmosphere packaging, all those things can be considered. And also the one more important thing is who is going to eat that product. If the kids are eating the product, infants are eating that product, if they are the consumer, then you have to give utmost importance. You have to come up with good plan. And if like adults, then definitely you have to give importance, but compared to kids, you have to give more importance to infants, and compromised people, again, you have to give more importance. Again, all these factors are very important, and that's the basis for all environmental monitoring program. And you can start with water activity and pH. These two are play a very important, like pH less than 4.3 or 4.4, or water activity of less than 8. Definitely those are some of the good factors that considered as like low risk products.
Okay, thanks, Kantha. Kuldeep's asking how to get rid of listeria from drains of the food processing area. Could you suggest a chemical that's most effective, but that's also allowed to be used in a food plant for getting rid of listeria?
Okay, recently, listeria is loves water. Okay, so drains you will always find a listeria monocytogenes, but you have to keep drains in. You have to keep drains in good shape. There is a foaming component that comes with the combination of quaternary ammonium, and I forgot the other chemical name. It's a foaming detergent that acts as a very good cleaning agent to get rid of the issues with the drains. Probably I'm going to send those informations in my next email to the
Okay.
exact chemical name and all those things. Please note that we don't endorse any third product services, third parties products or services,
Yeah,
just
and
for the
somebody,
information sake. Yeah.
thanks, Kantha. Somebody mentioned actually, Savvy mentioned in the sidebar, do not use high pressure hoses, on the floor or drains, because
Yes, sir.
obviously it can
Yes,
fire.
sir. Sometimes the cleaning with the high pressure hoses, it's not recommended, because the water particles, tiny water particles, bouncing back from the drains and floors, it can sit on the contact surfaces like zone 1 and zone 2. So it makes no sense, right? So as such, bacteria cannot fly in the air. So it's going to adhere to the dust particle or water, tiny water, minute particles, which you cannot see with your naked eyes. But definitely those things act as an agent or vectors to disseminate into the zone 1 area or product contact surface area. So that is not recommended.
Yeah, okay. I think one or two of the members have also asked if they continually get positive results on the floor. Is that an issue? What can you do about that if you continually get high results on the floor?
So sometimes it happens that you're getting continuous positives in floats, and definitely you need to consider that. To give high priority. Looks like it's more of a employee or traffic pattern. The moving the equipment from different areas, raw ingredients areas to the production areas, or employees moving, the boot cleaners and all those things definitely will help. And despite of all those things, boot sanitizers and hand sanitizers and people doing a good job, then you have to go for vector swabbing, and you have to make sure that you have to identify the source of contamination, fix it, and move forward.
Okay. Amit, I think this is an interesting question. Conducting environmental monitoring just prior to cleanup or several hours into production is something new. What is the purpose of conducting EMP in such an unclean environment?
So this is an important question. For all these years, we have been doing environmental swab samples. After the sanitizing, cleaning, and everything is done, and you make sure you collect the swab samples, and it's always negative. In most cases, that's obvious. Even with the little common sense, we can understand the situation, because the production is done, all the dust particles, all the uh, spills have been taken care. Again, it's sanitized, washed, rinsed, and definitely it's going to be in good shape. But recently, FDA came up with a new idea or concept. This is not the right way of collecting the harborage sites. So the best way is in the mid of operation. So the idea and the concept is that when the equipments are moving, okay, the machines are working, and the cracks and crevices, joints, and all those things, that is where most cases the food particles are hiding, and that's where the bacteria are growing. And when the machine is moving, and then there is you know good chance that bacteria that which are adhered to the dust particles falls on the contact surface. When the equipments are in stationary phase, definitely it won't fall, right? When you vibrate or when you shake, that's where there's a good chance that the bacteria can fall on the contact surface. So that's the concept, and it makes perfectly sense. Uh, Technically it makes perfectly sense. That's the reason why FDA is FDA came up with this new idea of collecting swab samples during the production and not after the production. And also, one point I want to mention here, the ultimate goal of EMP should be to find the positive samples in your facility. If I'm the QA person, if I'm starting the EMP program in my facility, my goal is to find the positive. It's not a big thing, find the positive means, you take appropriate corrective actions. Ultimate goal is not to find the negative. I want to see what's happening in your facility before the pathogen get into the product, then somebody eats and dies, and recall situation, legal penalties, then I have to shut down all those things. But before that, I want to address the contamination issue. So my aim, my focus is to let me see, I'm doing a good job of GMP practices, if not, let me fix it through corrective actions. So ultimate goal should be to find the positives.
Okay, just one more. If you do get a positive sample in zone one during production, what do you do? What do you do with the current production and production that may have gone out already to the customer if you find positive?
So, as I already told, the product testing as a sole means should not be the sole means of addressing food safety hazards in getting into the finished product. So, and also I clearly mentioned that you should not test zone one for pathogens, right? You can use indicator organisms effectively. If you come up with a good indicator organisms, good plan, you can always, make sure that you can, address the contaminations in issues in your plant. Not necessarily that you have to collect the zone one for Salmonella or Listeria monocytogenes or Clostridium botulinum. So zone 2, 3, and 4, you are finding positive, that's okay. And you take the necessary corrective actions according to the recently released guidance. Take the necessary corrective actions and make sure that the next 3 subsequent samples are negative. That should be fine. And if it is negative, then means you are fixing the problem. If still you are getting positive, means then you have to stop the production. Okay, but otherwise don't get panic. If zone 2, 3, and 4, in case if you get positives, don't get panic. You have to assemble your team and take the appropriate corrective actions, because zone 1 is not tested for pathogens, so there is no point of reporting to the regulatory agencies. So as I said, you have to have a comprehensive, EMP plan with a good indicator and good sampling frequency, good number of swab samples. As I mentioned earlier, you need to make sure you cover the food contact surfaces and non-food contact surfaces every time when you collect the swab samples. And suppose, for example, if you have 100 food contact surfaces, 100 non-food contact surfaces, those are sensitive areas, and make sure you cover all those things in a span of 2 months, or span of 1 month, and make sure you have a good integrated plan, and that way you can address the contamination issues. I hope this
Okay,
helps.
yeah, that's great, Kanta. Thank you. Right, I think this is the most questions we've ever had on a topic. But we've actually run out of time. We've run 5 minutes over. So what we'll do is we'll collate those and send those to the guys at AIB, and if there are any, we can follow up by email with those. But Kantha, I'd just like to say thanks very much for a very clear, in a short space of time, a very, very clear overview. Excellent presentation. Thanks on behalf of myself, all the audience here, everyone at the IFSQN, and lots of people will see this in future as well. So thanks, Kantha.
Hey, thank you so much, Simon. Thanks for the opportunity. And I hope this webinar was useful to you and everyone. And feel free to reach out to me if you have any questions. And I'll be more than happy to answer any questions related to environmental monitoring program. And you can provide my email ID. It's lchanaya@aibonline.org, or you can Google it, Kanta Chanaya. So you can get my email ID, and feel free to ask questions anytime. So I'll be more than happy to answer. I hope this was useful to you. More than anything, like no specific answers, I just wanted to convey the concept, and that is more important. Understand the concept, understand the science behind this environmental monitoring program, and if you come up with a comprehensive integrated EMP program, and definitely it's going to act as an early warning system in your facility. It's important. It's always important to know what's happening in your facility. Otherwise, it makes no sense. If I don't know what's happening in my facility, how can I confidently sell my products to the consumers, including kids, right? So it's very important. You should know, and this is the only way. There is no shortcut for EMP program. This is the only way. So come up with a good plan based on the risk assessment, and good luck with your program. Thank you so much.
Thank you, and we hope to see you back on one of these in the very near future, Kantha.
Yeah, sure. Thank you so much for the opportunity. Have a nice day.
Cheers.
Bye.
Thank you. So that was Kantha Chanai, Director of Microbiology at AIB International. I'm sure you'll agree, a fantastic presentation and a great speaker, and we hope to see Kantha very soon. I've loaded your certificate in the sidebar, so you can download that. Please, it's not got your name on. You need to print it and sign it, or open it in an image editing package and type your name. We can't individually personalise certificates, I'm sorry. Right, great. Food Safety Live next Tuesday. Be here, 10 Q&A sessions, 30-minute sessions, just like this, but 10 of them, lots of different subjects. So get your questions in, and we'll see you next Tuesday. Happy Friday, and enjoy your weekend. Speak soon.